Hello and welcome to Mr. Linford's Math 097 course. This is a presentation on section 4.3 of the text. And in today's talk, we're only going to be discussing the elimination method, a technique for solving a system of equations. Now we're going to be working with a system of equations in two variables, and what we want to do is we want to come up with a process for how we can actually go about solving a system of equations without having to do the substitution method. The substitution method, if you remember, means I have to solve one of these equations for a variable, and then I have to plug that variable, the expression that I get for that variable, I have to plug that into the variable for the other equation, and it gets a little complicated, a little messy, it can be a bit tedious. Well, we want to have a different technique for doing this, or another technique that might be a little easier. And this is called the addition method or the elimination method. What it says to do is, it says, notice that you have two equations here, like always, and they're of the same variable, but pay careful attention right here to these y's. You have a 2y and a negative 2y. The coefficients are opposites. So what we're going to say to do is, what would happen if we went and we added these equations together? And then, so let's say we added them together and we combine their like terms. So let's see, if I take 2x and x, I'm going to get 3x. If I take 2y and negative 2y, well, those just cancel out. And then this would equal 18. So x equals 6. This is a very easy and quick way of going about and figuring out what one of your variables is going to be for your system of equations. And if I want to figure out what the other variable is, well, just plug it back into one of the equations. I'll plug it in for, let's say, x. So 6 minus 2y equals 4, and then I can subtract them from both sides. So negative 2y equals negative 2. My handwriting is terrible. Oh my gosh. Y equals a 1. So my answer to this problem is going to be a 6 for x and a 1 for y. And what this is doing is it's saying, notice that if you have opposite coefficients, when we add these equations together, those opposite coefficients are going to cancel out. So the procedure would be, for step 1, make one of the variables, I'm going to get used to the stylus one day. Make one of the variables coefficients opposites. I'll abbreviate that. And then step 2 is just add together. So we're going to add the equations together, and that's really the essential idea. Now, a key component, I guess I could include this as one of the steps, but I'm making a big note for ourselves. Make sure the equations are in standard form. Remember, standard form is ax plus by equals c. So basically have your equations all lined up. We're going to use standard form in this case, but really just have your equations lined up. Have all the x's on one side, have all the y's on the same side, have all the plain numbers on a side. So typically what we're going to do is we want to just make sure everything lines up. So all the x's are lined up, all the y's are lined up, and so on. We don't want them to be like all messed up. Like let's say I had the equation 2x plus 2y equaling 14, and then the other equation was x equals 2y plus 4. These equations, though they're the same to the ones I was working with, I can't actually go about the elimination method yet, because these aren't on the same side of the equal sign. They're not really lined up. So we just got to be careful with that. But otherwise, just once you have everything lined up, we can go ahead and start adding it together. Now, notice here that I said make one of the variable's coefficients opposites. I wrote it very sloppily, but that's essentially what it says. Sometimes we might not have that case where, we have these nice, easy coefficients that are already opposites for us, 2 and negative 2. That might not be the case, but it's okay. We can go about making it that way. For example, let's take a look at this problem right here. Notice that my coefficients for y are both positive 2. Gosh, it'd be really awesome if one of them was negative 2. Well, it's a pretty easy technique. We can actually go ahead and turn it into that. Remember the multiplicative property of equality. What I multiply to one side of the equation, I can multiply to the other side of the equation and keep it being an equation. I don't change it. So what I'm going to do is say, why don't we multiply the bottom equation, close enough. Why don't we multiply that bottom equation by negative 1? So let's see what we end up with. 4x plus 2y equals 24. I didn't do anything to the first one, but the bottom one, I get a negative 3x, a negative 2y, and a negative 20. I'm allowed to do this because all I'm doing is I'm just multiplying both sides of the equation by the same thing. That doesn't change an equation. You are allowed to do that. So right here, these y's cancel out. And that's exactly what we wanted, because now let's combine the 4 and the negative 3x. That just becomes 1x equals 4. So x equals 4, and then I can plug this in and figure out what y is going to be. So 4 times 4 plus 2y equals 24, so that's 16. So 2y equals 24 minus 16 is 8. So y equals 8. There are my two values. X is going to be 4 and y is going to be 8. This idea shows us that, yeah, remember, I can multiply both sides of the equation by the same thing. This idea is going to be helpful for when we have some problems where the coefficients aren't even close to being the same thing. For example, let's take a look at this bottom one, and I'll change colors here. I have a 3x and a negative 4y, and I have a 4x and a positive 1y. So none of these are even close to being similar. I can't go about just adding them together or multiplying both sides by negative 1. Nothing would cancel out. So what I'm going to have to do is, well, instead of multiplying by negative 1 like I did in the previous problem, what if I just multiplied by some number? So let's pick one of the variables. Pick a variable to cancel out, x or y. I'm going to pick y because it looks easiest for me. So I'll pick y to cancel out. I want to make the coefficients of y, I want to make these things opposites. I want one to be a positive 4 and one to be a negative 4. Well, if the top one's already negative 4, let's multiply the bottom by positive 4. Let's multiply that and see what we get. 3x minus 4y equals 2, and 4x plus y equals 9. But if I multiply this bottom by a 4, it's going to turn into the 3x minus 4y equaling 2, and 16x plus 4y equaling 36. This is going to give me the coefficients that I want, so they cancel out right away. And we're left with a 19x equals 38. So x should be 2. And what do you know? We already solved the equation. Very quickly, we solved for what x is going to be in this system of equations. Very quickly, not that bad. The elimination method is typically preferred among students, but it's really what you like. Some students absolutely love doing substitution. They're like, nope, that's my method, that's what I'm sticking with. Other people are saying, nah, elimination's easier for me. Pick which one you want. Both are valid methods. Now, if I want to go and solve this for y, I'll change colors here. Let's go with green, and let's plug it into one of the original equations. In this case, I don't know, they both look about the same difficulty, so I'll just plug it into the first equation. 3x, well, x is 2, so 3 times 2 minus 4y equals 2. So 6 minus 4y equals 2. Negative 4y equals, well, that's a negative 4, so y equals 1. This is going to be my solution, 2 and 1. That's the ordered pair for these two values. Now, sometimes we're going to get weird solutions even with the elimination method. So let's take a look at a system that's dependent. Remember, a dependent system should have infinitely many solutions. Well, if we're going to start working with this equation, very first thing we got to do, I'm not working with fractions. There's no way I'm working with fractions because they're too messy to work with. And now I'm going to have to multiply by some fraction value? No, I don't think so. So what I'm going to do is I'm going to go ahead and clear the fractions. So let's multiply this top equation by the least common denominator. What would that be? Or a common denominator. We have 5 and 2, so it would be 10. Let's multiply this top equation by 10, just to simplify and see what we have going on. So 10 over 5 is 2x, minus 10 over 2 is 5y, equaling 10. Notice that I didn't forget to multiply the 1 by the 10. I made sure to include that point because we have to make sure we're distributing to everything. It's important that you multiply both sides of the equation by the same thing. I can't tell you how many times I see students go about and just multiply the x and the y by the 10, but they don't do anything with the 1. You have to preserve balance. To do that, we said you have to multiply the left and the right side by the same number. All right, well, this equation is much easier to work with. And we end up with the bottom equation being negative 4x plus 10y equaling negative 20. Well, this isn't too bad. I gotta make a common coefficient, or opposite coefficients, I should say. So let's pick one of the variables to cancel out. Maybe I cancel out x this time. So let's multiply the top equation by 2. So I end up with a 4x, a negative 10y, and a 20. And then the second equation, well, that's a negative 4x, a 10y, and negative 20. These are all opposites of each other. If I went to add these together, they would all cancel out, and I would get 0 equals 0. What is 0 equals 0? What is that? Well, that's a true statement. And that's just something that's always true. The variables canceled out of this whole thing. So this is a true statement I'm left with. What we have right here is an identity. An identity. Remember, this is a dependent system. We're essentially working with two lines that are the exact same thing. You have one line and then you have another line on top of it. They're the same function, they're the same equation, let's say. Well, an important idea here is that if I'm going to be, adding the opposite coefficients together, they should just all cancel out because I'm just adding kind of the opposing values. So they're just going to go ahead and cancel out, and I'm going to be left with an identity. This has infinitely many solutions. There's infinitely many intersections. Okay, now let's try and look at an inconsistent system. Remember, an inconsistent system had no solution. That was the important thing with an inconsistent system. Well, if I'm looking at this system right here, I notice right away that my variables aren't lined up. I got to get them to be lined up on the same side of the equation. So I'm going to move this negative 3 to the other side. So I have 3x plus 2y equals 4. And the other equation is 120x plus 80y equals 40. I totally just wrote 8 instead of 80. There we go. Okay, we need to make these opposite coefficients. I guess we'll try to cancel out the y's this time. So let's multiply the bottom equation by negative 40. So we end up with negative 120x minus 80y equals that should be negative 160. And 120x plus 80y equals 40. Let's add these together. They all cancel out, and we're left with 0 equals negative 120. Oh, well, that's weird. 0 can't equal something like negative 120. What's going on here? That's a contradiction. Well, remember, a contradiction tells us we have no solution. There's nothing that will work. And this is an inconsistent system. This system, I'm guessing these are two parallel lines. Because for a system to have no solution, that means that there is no place where the two lines intersect. So I'm assuming here that we're going to have no solution, but at the same time, I'm suspecting we have two parallel lines. You could see this by if you want to go about graphing them. But this is a general idea about what the elimination method is and how it's used. We're going to use it in the next few sections when we go about and actually start trying to solve systems of equations in 3 variables. Well, until next time, if you have any comments or questions, feel free to contact me at Linford, Linford, at wccnet.edu. Let me know what you think of the video, and if you have any questions or comments, feel free to let me know as well. Until next time, take care.